Heyo, it's Mr. Otwell, the Math Master, helping you master math. And today we're going to be simplifying some square root expressions. This time we're going to have some variables involved. It gets a little more interesting. Stick around. I have a little tip that will save you some time if you end up seeing an example like this. And as always, give me a thumbs up if this video was helpful. Subscribe, hit that notification bell, and leave a comment just saying, show Mr. Otwell some love. So let's do this. So now let's throw in some variables. It wouldn't be algebra 2 without the variables, right? So in this case, we've got a square root in the denominator. Can't have that, gotta simplify it. So I kind of wrote some different steps for this because this is a little bit of a unique situation where there's kind of a shortcut that we can take and it'll just save us some time. So if you have only one term in the numerator, like it's not a bunch of stuff added or subtracted, and you only have one term in the denominator, there's not a bunch of stuff added and subtracted, you actually can go about it a little differently and it'll save you a bunch of time. The first step is going to be write all of your variables under one radical. Now, how can you do this? The property we're going to be utilizing is if we have the square root of x over the square root of y, that's equal to the square root of x over y. We're able to take anything in a radical in the numerator and anything in a radical in the denominator and put them all under one radical. If they're both square roots, it's just going to be a square root and we'll have that fraction inside. So we can do that here. So we'll be able to utilize this property and save ourselves a bunch of work. What we want to do is separate our numbers from our variables so that we can just kind of hone in on the variables. So the numerator is a square root of 5, so it's still going to be in the numerator. And our denominator, this 3 would still be there, and there's still a square root of 6 as well. We want to move that over as well. Times, now every one of these variables we can put under one square root. We can just have one really big square root, and it would be x squared y cubed on the top and x y cubed on the bottom. Now, why am I doing this? Well, if your expression starts like this, and you can set it up like this, we can just use exponent properties right now and simplify a bunch of stuff, and it just saves us so much time when we're trying to simplify it later. If we have x squared on the top, x on the bottom, this is like two x's multiplied together, right? So we could divide one of these x's with this x on the bottom. So instead of x squared, this would be just become x to the 1 power. And then here we have y cubed on the top, y cubed on the bottom. We can divide the top and the bottom by y cubed. So that simplifies. So what's really nice about this is we still have the square root of 5 here, and we still have 3 square root of 6. I'm just rewriting this. But what have we just done? Well, check it. All the denominator just got canceled. So now we're not even going to have variables in the denominator. And we were just left with one x on the top. So it's still under the square root though. Don't forget that. So we have the square root of x, and the denominator is just a 1. When we divide everything out, there's a 1 left there. So now our expression turned into this, from this crazy thing right here, into something a lot more simple. If we multiply across and follow our fraction multiplication rules, on the top, remember, if we have two things under the square root, we can bring them under the square root together. The top will become square root of 5x, and they're both under the square root. And the bottom will just be 3 square root of 6, because 3 square root of 6 times 1, it just stays the same. So we get 3 square root of 6. So now, isn't this better? This crazy, scary thing just turned into this not so scary thing. It's nice, I think. I mean, come on. So we've done step 2 here. We simplified the variables using exponent properties. Now on to step 3. We want to simplify the square root in the denominator. Well, we can't do that. Like it's already as simple as it gets. Square root of 6, we can't simplify more, so let's go to step 4. Using the square root in the denominator, multiply by a clever form of 1. Hey, that's what we've been doing, right? So we want to multiply by a clever form of 1. What do we want our denominator to be? Well, the goal is to get rid of the square root of 6. So we want to multiply it by the square root of 6. Remember, if we need a square root of 6 on the bottom, in order to make this a clever form of 1, we need a square root of 6 on the top, because this divided by itself is 1. We're not changing the expression, which is key. So then once again, we multiply across. Gonna follow our fraction rules. If we have something under the square root and another something under the square root, we can put all that under the square root. So we have a 5x times 6. The 5x and the 6 we can bring under 1 square root. Divided by, the 3 is outside the square root, so we leave it there. And then the square root of 6 times the square root of 6 is just 6, which is nice. If you think about it, anything times itself is that thing squared. And the square root of 6 squared simplifies. These are inverses. The square root and a squared cancel each other out, leaving you with just 6. So that's another way you could think about why this is happening. So now we just simplify what we've got left. That's the next step. So we've got a 5x times 6. I mean, there's nothing else we can do. 6 has a factor of 2 and 3, so it's not really going to combine with the 5 to be able to simplify or anything. So let's just go ahead and multiply the numbers. 5 times 6 is going to give us a 30, and it's going to stay in the square root. We can't bring it out. And then the x is still there, so we leave it. All over 3 times 6, which is 18. So what we have is this crazy thing, when simplified, simplifies into this nice, beautiful thing here. And really, we could check to see if our solution was equal. We could just give x and y some value. It gives us a number. And then we just use that same x here and calculate it, and we get the exact same answer. So now let's take a look at a different problem. In this case, we have 2 terms in the numerator. So we can't do what we did here. Because you have 2 terms in the numerator, you cannot combine these square roots. That property does not hold in this case. So really, we're just back to square one. This is just a standard simplifying square roots question where we just need to get rid of that square root. All this stuff up here does not change what we need to do, because all our goal is to get rid of that square root of 5x. So if we want to get rid of the square root of 5x, what do we got to do? I heard somebody, you said it, multiply by a clever form of 1. And you're absolutely right. Look at you, learning. So good. Good job. So what do we need to multiply by in the denominator? Whatever is in this square root. We just need to multiply by this thing again. Square root of 5x. So if we multiply the square root of 5x times the square root of 5x, that square root will cancel. The variables don't change anything. We just take whatever that factor is, the square root of 5x, and multiply it by the square root of 5x. But remember, clever form of 1. So if we need a square root of 5x in the denominator, it's got to be in the numerator as well. So we need to multiply by the square root of 5x over the square root of 5x. So when I have multiple terms in the numerator or denominator, what I like to do is go ahead and put some parentheses around it. This is just a visual cue for me. Hey, you need to distribute. You have to distribute. Because look, I have a 2 and a negative 3 square root of 10x, and I'm multiplying it by one thing, square root of 5x. This would be the same as if you just had like 2 minus 4x times 3. If you had the 3 outside the parentheses, you would distribute that 3 to all the terms. It's the same thing going on here. So now let's distribute. We need to distribute the square root of 5x times the 2 and the square root of 5x times the negative 3 square root of 10x. So first, we've got a 2. It's outside the square root. We don't have anything outside the square root here. So that 2 just stays on the outside of the square root. And then the square root of 5x is just going to stay in the square root. Then we have to multiply this times that. What I like to do before I even think about that is I think about the sign. I've got a negative times a positive. So that's going to give me a negative. Then let's think about the multiplication. We have 3 square root of 10x times square root of 5x. The 3 is on the outside of the square root, so it stays there. So we're still going to have a 3 on the outside. Remember, we can take everything under the 2 separate square roots and put them under 1. So this will become the square root of 10x times 5x. Then all this is all in the numerator. That's our numerator. Now we want to multiply what's in the denominator. Now let's not think too hard about this, okay? The 3 is outside the square root, so it's just staying there. Our 3 is still outside the square root. Now, why did we multiply by the square root of 5x on the bottom? Well, because that's going to cancel out that square root. So this, the square root of 5x times itself is just 5x. This will cancel the square root. We're squaring the square root, basically. So now, once we do that, hey, simplify what's left. That's the next step. So we always simplify what's under a radical, so we want to check everything under these radicals, okay? Here, this term, we can't do anything with it. This is still just going to stay 2 square root of 5x. Now this term though, take a look. Underneath the radical, we have a 10 and a 5. So we can actually do something with this. I don't like multiplying the numbers because really I want factors. Factors are my friends here. Because if I have 2 of the same factor, since I have a square root, that will simplify and will be able to be taken out of the square root. So it might help us to just write our work of simplifying this down on the bottom. So we have 3 square root of 10x times 5x. So let's simplify this. Well, 10 has a factor of 2 and 5. Why is this good to write out? Well, check it. We have a factor of 5 here, and we have a factor of 5 here. 5 times 5 is the same as 5 squared. That's good, because that's a perfect square factor. 5 squared is 25. And remember, these 5s are under the square root. So really, this gives us the square root of 5 squared. Remember, the square root and the squared undo each other, just leaving us with 5. And that factor of 5 is on the outside of the square root now because we canceled the square root, having the square root squared, and those canceled out. So this 3 is still a factor on the outside, but now we're going to have a factor of 5 as well because we took these 2 5s here and did the square root of 5 squared to get our 5 on the outside. So now we've simplified these factors. We've used these up to simplify. So what's left inside? Well, we still have a 2, an x, and an x. Well, check it. What's x times x? X times x is x squared. And remember, it's under the square root. So we have the square root of x squared. What does the square root and the square do? They undo one another. They're inverse operations. So these get canceled out, just leaving us with x. And this x will be on the outside of the square root because we've undone the square root. Now really, this would give us the absolute value of x. If you want to know why, go take a look at my simplifying radicals video. But realistically, most Algebra 2 classes and college algebra classes don't deal with simplifying it by the definition. Most of the time they just keep it more simple, and so we're just going to leave this as x. So now we've utilized this x and that x. Now all these factors have been used up in our simplification process. They've come outside the square root, but there's still a 2 in the square root. So we can't forget it. We have to write square root of 2 right there. Now we want to go ahead and multiply all this stuff. 3 times 5 gives us 15. The x is still there, so we leave that outside the square root. And then we have the square root of 2. The square root of 2 stays inside. So when we simplify all this, we get this. But notice though, it's minus all this. So don't forget your minus sign. Minus 15x square root of 2. And that's our numerator. Now we can multiply 3 times 5. That gets us 15x. And this is our solution. So once again, you can end up doing a little more simplifying because of the variables going on and everything. But if you just have a square root in the bottom, even if there's variables, it doesn't matter. You just take that square root after you simplified it and multiply by the same square root in the bottom. Because remember, you can cancel out the radical that way. And then you just have to make sure you're simplifying everything else that you end up with. Don't forget distributing right. If there's more than one term in the numerator, once you multiply by something new, you're going to have to distribute that term. So keep all these things in mind. So hopefully you found this video helpful. Let me know, was separating these variables into its own expression helpful to get that little shortcut? Leave me a comment down below. Make sure to subscribe, hit that notifications bell. And for the next video where we talk about some more interesting examples, hit that button right there. It'll take you right to the next one. Mr. Otwell out. Peace. So let's erase some of this little, 3 times 5 is 3. What are we even doing? Not using that either.